Hey y'all. Just need to click off of that. All right, today's lesson is distance on a coordinate plane. And so I told you to tear out these pages from your textbook. 381, 382, and then 383. And I maybe told you to tear out 384. So get that one too. Uh-oh, it looks like it's zooming in and out. So let me fix that because I cannot have that. Okay. That would just be crazy. Okay. Hopefully it doesn't keep zooming in and out. All right, so on the first page, distance on a coordinate plane. We maybe have talked about this a little bit, but we're going to use over here, this is the TEAC, this is the standard. Determine the distance between 2 points on a coordinate plane using the Pythagorean theorem. And so I'm going to show you two things today. I'm going to show you how to use the Pythagorean theorem for a coordinate plane, and then I'm also going to show you a way to find it without graphing a variation of the Pythagorean theorem. And so this is just kind of to get you thinking about it. Evan was biking, and here's a map. How can you determine how far Evan rode from point A to point B? So it looks like he biked some sort of horizontal, or he biked up kind of this line. And then we are going to build a right triangle to figure out this distance because you can't really count across these squares like that. So question number one, what do the blue and red lines represent? Well, my picture is black and white, but I feel like, if I remember, okay, the blue lines are the horizontal and vertical distances. I think these are blue. I could be opposite. I can't remember. And then the red would be the direct distance or the diagonal distance that Evan rode. And if I'm backwards, let me know. But I don't have a copy in front of me of the colored page. So what type of triangle is formed? And we have a right triangle. And when you have a right triangle, we can use the Pythagorean theorem. Now it says, how can you find the length of AC and BC without counting the number of grids? So the easiest way would just say, oh, well, let's just count 1, 2, 3, 4. But it's asking, how can we find it without counting? And if it moved horizontally, this is AC. If it moved horizontally, see how look at the points, 3, 4, and 7, 4. Well, the 4s are the same because it didn't go up or down. So from 3 and 7, what can we do with those numbers? And we could subtract 7 minus 3 to get 4. And then BC, let's look at this line. Without counting, if we just counted, that would be easiest. But if we couldn't count, how could we find the distance of BC without counting? And again, the answer would be we would subtract 9.5 minus 4, which is 5.5. And then what are the lengths of the two blue lines? So AC, we said, was 4 units, and BC, we said, was 5.5 units. And then the last one, write an equation using the Pythagorean theorem that you can use. So again, the Pythagorean theorem starts with a squared plus b squared equals c squared. A and b are the legs. They make up the right angle. And right here is our right angle. So A and B are the legs. So one leg is 4 units long. The other leg is 5.5 units long. And then that would equal the hypotenuse. The hypotenuse is always across from the right angle. The hypotenuse is always across from the right angle. Now, it just says write an equation. It doesn't actually say solve. If you wanted to solve it, we could, but we're not going to solve it. This is just getting you to think about what the lesson is about today. Okay? So go to the next page. 382. Okay, determine the distance on a coordinate plane. You can use the Pythagorean theorem Determine the distance. So let's just write it again. A squared plus b squared equals c squared. Example 1 right here is done for you. This is a great reference to go back and look at it. It shows you they plotted the points, they made a right triangle, and then they used the Pythagorean theorem. Notice they used the squiggle lines, which means about, because they've rounded. So we need to make sure we use the about. And they used a calculator, which you'll be able to use a calculator. Okay, and then here is a little note. So we are going to do it for this. Got it. First, we need to plot these points. All right, so make a note. We need to plot these points. Go ahead and plot 1, 3, and -2, 4. And we want to connect them. Okay. Now, we cannot just count that distance because it's slanted and it goes through, so we need to make a right triangle. And I'm using my black pen to make a right triangle. I don't know if you can see that. I'm making a right triangle, and I'm just going to count the grids. So right here, my vertical distance right here is just one block, one unit, one grid. And my horizontal is 1, 2, 3 right there. Now I know my legs. Uh-oh, I need to go back to my blue pen. I don't like my black pen for some reason. Do y'all have like a pen that you like better? Like this one just writes really smooth, and I like the way this one writes, so I just prefer to use blue. One leg is 1 unit, and the other leg is 3 units, and I'm looking for my hypotenuse, because remember, the hypotenuse is always across from the right angle. 1 squared is 1, 3 squared is 9. 1 plus 9 is 10. And then I need to take the square root, which I haven't opened my calculator yet. So the square root of 10, the square root of 10 is going to be 3.16. And then the directions say round to nearest tenth. So C is about 3.2. Hey. Miss Johnson just came in. You tell her, hey. All right, now there's not another example, so I'm making up an example for you over here. We'll call this B, and plot these 2 points, 0, -5, and 3, 2. So here's a U-try. Just plot it on this grid. Use the same grid. Plot those 2 points and draw your right triangle, and then pause it, and when you're ready to see the answer, press play. Are you staying or are you leaving? Okay. All right, 0, -5, and 3, 2. Oh, this is far. I just made this up. So once you have drawn, obviously mine's not straight, it's up to you if you make your right triangle above the line or below. I'm just going to go below so I don't cross into that other triangle. It doesn't matter. Your right triangle is going to be the same. And remember, when we're doing distances, we're going to take the positive value. So my leg right here is 1, 2, 3 units. And 1, 2, 3, 4, 5, 6, 7 units. So those are your 2 legs. Remember, your legs make the right angle. Your 2 legs are adjacent to the right angle. So 3 squared plus 7 squared equals c squared, and your hypotenuse is always across from the right angle. 9 plus 49 equals c squared. So this is 58 equals c squared. We're going to take the square root of both sides, and we're going to have to estimate, and the square root of 58, notice I'm putting in my calculator, no shame in that game, is 7.61, and we want to round to nearest tenth. So C is about 7.6 units. So that would be the distance on the coordinate plane. That would be the distance. It's about 7.6. And it should make sense because the hypotenuse has to be the longest side of the triangle. And so the hypotenuse is longer than 3, and it's definitely longer than 7.6. All right, so now we're on to the distance formula. The distance between 2 points is given with this long formula. And I know it looks confusing, and I'll explain it to you. But this can be used with 2 coordinate points without graphing. So the examples I've shown you is if you actually graph them and make a right triangle. But we have a formula here that you would just plug in and then you wouldn't have to graph them. So I'm going to show you that example. All right, so the next page, top of 383. And it gives you, sorry, I hole punched. Not sure. Between 2 points. And it gives it to you, up here it shows you how the Pythagorean theorem relates to the definition, or the distance formula. So we've been using the Pythagorean theorem, and you still can, and then they just showed you mathematically how they're substituting. You remember how on this first page we subtracted to find the difference in the horizontal and the vertical? So it's just showing you how that relates to the Pythagorean theorem. The horizontal distance and the vertical distance. And then you take the square root. Again, they have an example using Fort Worth and San Antonio. And we are going to do another example over here. We're going to call this, this is B. So this maybe is A. We're just going to call this A. We're going to use the same 2 points that we just used. 0, -5, and 3, 2. And without graphing them, we already know the answer is 7.6, but without graphing them, we're going to use the distance formula. So I'm going to start with my equation. Let's always start with our equation, and it's written right here for you. Hello. That's my friend. x2 minus x1 plus y2 minus y1 squared. Don't forget you got to square both sides. And here is a tip that will help you if you go ahead and label. The first coordinate is x1 and y1, and the second coordinate is x2 and y2. If you go ahead and label that, that will help you. And now we're just plugging in into our equation. This is the distance, and it's equal to the square root of x2 minus x1. So x2 is 3, and x1 is 0. You square that, and the reason we're squaring it is because it was originally the Pythagorean theorem. y2, which is 2, minus y1, which is -5 squared. And remember, when you subtract a negative, that's going to become plus. Distance equals square root. Yes, you need to write the square root every time. And these parentheses are important because we've talked about the difference between -5 squared and -5 squared. So it's really important that you remember these parentheses because your base is going to maybe be negative. Maybe not in this example. But 3 minus 0 is 3 squared. 2 plus 5 is 7 squared. And 3 and 7 should look familiar from the example we just did. The distance is equal to the square root. 3 squared is 9 plus 49. The distance is equal to the square root of 58. And then we already know that the distance is about 7.6 because we already did this example. But this is how you use the distance formula. We didn't have to graph it. We didn't have to count. We just plugged it into our equation. All right, so you try this one right here. You try this problem. Pause it, and then press play when you're ready to see it. Look, this is my middle name. I mean, my maiden name, Dito. I don't know where Dito Field is, but. All right, so we have our 2 points, x1, y1, x2, y2, and we're going to plug them in to the distance formula. 1.5 minus 2.5 squared, 4.5 minus 3.5 squared. Whoops. Oh, I'm going to run out of room. All right, 1.5 minus 2.5 is -1 squared. 4.5 minus 3.5 is 1 squared. -1 squared really means -1 times -1. So that would just be 1. 1 squared is 1. So I have the square root of 2, which I think is about 1.4. Yes, so the distance is about 1.4 miles. All right, I hope you got that one correct. And then the third page, or the fourth page that you probably have, I think already just has an example on it, and it shows you, again, the distance formula with 2 points. And this one has some negatives, so please go back and look at that. And again, it's just important to keep your parentheses, especially when you have your negatives, because negative 8 squared is really 64. All right. We will probably start with our guided practice in class tomorrow, and I'll see you next time. How do I stop? Oh, yeah. Control, Shift.